I am going to solve this problem 134. So in the previous problem we have discussed that this difficult to access wrench has some shortcoming. It is producing the moment about x-axis which is not desired, right? So now in this problem it is said that in order to decrease the undesirable moment about the x-axis, right? So as we have discussed in the previous problem that the moment about x-axis is like this, right, in the positive x direction, right? So this is the moment produced by the application of this force, right? So it is said that in order to decrease the undesirable moment, a mechanic uses his left hand to support the wrench handle at point B, right? So the mechanic will apply the force at this point B in order to decrease this undesirable moment at this point, at this x-axis, right? So it says that what upward force must be he exert in order that there be no moment about x-axis, right? So here we need to determine the magnitude of this force in order to have the moment about x equals to 0, right? So we need to require the magnitude of this force applied by the mechanic left hand, right? So and then it says that what then is the net moment about O. So what is the net moment about O? So we will calculate that net moment about O. So now if we look into these two forces from this direction, right? So I will solve this by using the inspection method, right? So if we look into these two forces from this direction, right? So this 40 Newton force is producing the moment about x in this direction, right? And if we curl our right hand fingers, so the thumb will point out in this direction. So the moment due to this 40 Newton force at this point A is in this direction, is in the positive x direction. And what will be the magnitude of that? So I will write that the magnitude of that is 40 into the perpendicular distance from this x-axis, right? So this is the perpendicular distance of this 40 Newton from this x-axis. So this is 300 mm. So I will write 300. And now if the mechanic is applying force at this point B, so again if we look into this force from this direction, so this force is producing the moment in the opposite direction to this one. So this new force is producing moment in this direction, right? And if we curl our right hand fingers, so this new force is producing moment in the negative x direction, so our thumb should point out in this direction, right? So this means that this 40 Newton's force is producing moment in the counterclockwise direction, right? And this one is producing the moment in the clockwise direction. This is clockwise and this is counterclockwise, right? So both of these need to cancel the effect of each other so that the moment about x should be equal to 0, right? So in other words, this means that these two moments should be equal, right? So I will write that the moment due to this f is equal to, so this is f and the perpendicular distance of this f from this x-axis is 150 mm, right? So I will write 150 mm, right? So this is the moment due to that 40 Newton force at A, and this is the moment due to that f that we are required to find, right? So then the force applied at point B by the left hand will be equal to 40 into 30 divided by 150. So this will be equal to, so this will be cancelled out, this will be 2 and this will be 80 newtons, right? So this is the force required to make the moment about x-axis is equal to 0. Now we are required to find the net moment about O, right? So as these two forces are cancelling the moment about x, so there will be, if we look into these two forces from this direction, right? So they will be producing the moment about z-axis as well, right? So this 40 Newton force will produce moment about z-axis in this direction, right? And if we curl our right hand fingers, so the direction of the thumb will be in the negative z direction, right? So this is again, this is clockwise moment, and this new force at this point B is producing moment about Z in this direction, right? And if we curl our fingers, our right hand fingers in this direction, so the thumb should point out in this direction, right? So this will be counterclockwise, right? And this moment is due to this F, which is 80 Newton that we have calculated, and this moment is due to F equal to 40 Newton, right? So one is in the clockwise and the other one is in the counterclockwise, but both the moments are about Z axis, right? So I will write that the moment about Z axis is equal to, so first if I write this moment, so this will be, since it is the clockwise and it is in the negative Z, so first I will put minus sign, minus, and this will be again 40 into the perpendicular distance. So the perpendicular distance between this 40 and this Z axis is 125 plus 100. So this will be 225, right? And I will write K, since the moment is about the Z axis, right? And then I will write, since the moment due to this 80 Newton force is counterclockwise, so I will write plus, and it will be equal to 80, this 80 into the perpendicular distance. So this is the perpendicular distance, this 100 mm, right? So I will multiply this with 100, and again this is about Z axis, so we will write K. So this means that it is minus 40, and if we divide this by 1000, so this will become 0.225 plus 80, and this 100 will become 0.1, and this all moment is about K axis, about the Z axis, so this will be the moment about Z, and if I solve this, so this will be the net moment about Z axis. When we solve this, so this comes out to be minus 1 Newton, minus 1 K, and the units are in Newton meters, right? So the resulting moment is in the negative Z direction, right? So, and this means that that moment will be clockwise moment, right? So in the previous problem, as it was given that this wrench should be used with the bolts having low torque specification, right? So this is very low torque, minus 1 Newton meter, right? So in order to cancel the moment about X, we have to sacrifice the moment about Z as well, right? So in the previous problem, when there was no moment about this point B, so what was the moment about Z? So we can calculate it again by inspection method, right? So this was the moment, that is the 40 multiplied by this 100 plus 125, right? So 100 plus 125, so this becomes 0.225, and this was equal to minus, this was in the negative Z direction, so this was minus 9 Newton meter, right? So now we have this moment, this is minus 1, which is very less than this moment about Z, right, in the previous problem. So we have to sacrifice some moment about Z as well, right? So this difficult to access wrench is only recommended when there is difficulty to access the bolt, and the bolt with having low torque specification, so then it should be used. Otherwise it should be